All right, so figuring out how to insulate these, the framing on the shop. Installation's coming pretty soon, so even with the insulation up, it'll only come up to maybe about right here. And so what I'd like to do is insulate the face of the frame with something just to keep some of that heat from emanating into the room, because the frame itself actually gets pretty hot. So kind of wanted to show you guys a little experiment to show you just how important the R value is on insulation. So what I have here is a multimeter, and it's got a temperature setting on it. So you plug in a thermocouple and basically you direct contact, place it on the frame, and it'll take the temperature. So I also have a little piece of fiberglass insulation, and so basically the way I took data was to place the thermocouple on the insulation and then place the insulation over the top of that. Basically it allows for the thermocouple to measure the temperature of the frame without air currents and things like that affecting the temperature reading. So you don't want to put like a big swath of insulation over it, because you'll actually prevent the heat transfer into the room off of the frame, and so you just want to get that local temperature as much as possible. So I took the temperature right here where the frame actually connects with this kind of like horizontal mounting beam, or maybe outer frame if you want to think of it like that. And so basically the heat transfer that's taking place is the sun is hitting the exterior of the shop at between the radiant heat and the actual convection. Heat is transferred to the sheet metal, which is then transferred to the horizontal beam, and then at the joints is transferred to the vertical beam. And so I kind of thought going into this that there's like enough steel there to allow enough thermal resistance that there's not a whole lot of heat transfer, but that's not the case. Metal's a pretty good heat conductor, so still gonna have to insulate something, but I'm gonna go through some math with you guys to show you exactly how the R value works and why it's important, and you can't really cheat the system. So anyways, all right, let me show you the insulation I'm working on. All right, so the first installation kind of method I'm gonna look at here is this bubble wrap foil kind of your radiation insulation, right? So this is for like your radiant heat. It normally gets put in like an attic space or something like that to prevent the actual like radiant heat from coming onto the insulation bed at the top of your house. So it's a little cheap. It's also pretty thin, pretty easy to just either tape on, zip tie on, or something install. So I went ahead and tried this, placed it on the beam, and left it there to acclimate. Took the temperature just as I showed you on the bare metal. Same spot where the horizontal beam joins with the vertical beam, and took the temperature there. So this is primarily for a radiant barrier. It's not for conductive heat transfer like this. So had pretty low expectations. The packaging says when it's used in this application, it's supposed to have an R value of about 1 to maybe 2. So don't expect a whole lot on this application, which I didn't, but kind of just wanted to see what I would be able to get out of it. So this was kind of the first case that I looked at. All right, so the next case I looked at was their kind of standard fiberglass insulation, pink fiberglass, and this particular fiberglass has an R value of about 6.7. It's maybe about 1.5 inches, 2 inches thick. So I laid it over itself, so I should have an R value of about a little over 13. And zip tied it to the frame, and again took the temperature where the crossbar meets the vertical frame, and used again another piece of fiberglass insulation over the top of the thermocouple to take an accurate temperature. So what I also did was I also took a temperature reading on the exterior of the shop, and so we'll use that in the math. I did it with the same method. I'm not going to go out there and kind of mimic that right now because it's early in the morning, the sun's not up, and you probably hear the crickets chirping in the background, so oh well. All right, so gonna do a little bit of math here, right? Just a little bit of comparative analysis with some basic heat transfer equations. We're not getting too deep into the weeds, mostly because I'm not willing to go through the rigmarole to look up all the material properties and everything else, and you don't really need to do that for what we're trying to get at. So with a comparative analysis, you're not really trying to get to like the exact number, you're just trying to compare situations. It makes it really easy to do the math. So if you don't know, the R value of insulation is related to basically the temperature change across a medium per unit of heat flux, and heat flux is just the amount of heat per an amount of area, right? So The R value basically measures the ability to block heat transfer. And so that's the basic relationship right there. And then the actual amount of heat that's transferred is based off of the heat flux through a given area. So that's how those values are related. And then a very generalized form for convective heat transfer utilizes an average of the convective heat transfer coefficient times the area times the difference in temperature. So using those basic equations, we'll do a comparative analysis, right? And we're going to consider it for this Q0 for just the bare frame, Q1 for the bubble insulation, and Q2 for the fiberglass insulation. We're also going to assume that the convective heat transfer coefficients for the steel, the bubble insulation, and the fiber are all equal, so that way we can cancel them out pretty easily. And so we're going to do that comparative analysis here. So basically by doing a little bit of algebra, right, you set everything equal to 1, and then because both sides are equal to 1, you can compare Q0 to Q1. Because the H's are equal, the A's are equal, those cancel out, so all you're left with is your Q's and your differences in temperature. If you're not aware, delta T, this triangle symbol is just a symbol for difference in temperature. So the difference in temperature between the room and the bare metal was 3.4 degrees Celsius. For the bubble insulation was 3.27 degrees Celsius, and for the fiberglass insulation was 1.39 degrees Celsius. And so plugging in those differences in temperature for your bubble insulation, the heat transfer through the bubble insulation was about 95% of the original bare metal heat transfer. So only about 5% of the heat transfer with the bare metal was blocked by using the bubble insulation. So going through this same process again for the fiberglass insulation, the fiberglass insulation heat transfer rate is 0.4 of the bare metal heat transfer rate. And so what that basically means is about 60% of the heat transfer of the bare metal is blocked with the fiberglass insulation. All right, so once you compare the percent changes in temperature to the from the bubble insulation and fiberglass insulation, you compare those to the bare metal, there's 4.8% change in temperature with the bare to bubble insulation, and from the bare to fiber insulation, there's about a 60% change in temperature difference. And so the ratio of those differences, so if you take the difference you get between the bubble and the bare and the difference you get between the fiber and the bare, that ratio is about 12.33. So that's pretty significant because that's a relatable number to our R value, which is kind of your measure of how effective you are blocking that heat transfer. So because we're comparing from a bare metal to a insulated scenario between bare and bubble and bare and fiber, we can kind of get that comparison of what the effectiveness of that insulation is. And so the ratio of those differences between those two types of insulation is about 12.33. The R value for the bubble insulation is about 1 is what the packaging says, and then for the fiberglass insulation it's about 13.4. So at 12.33, 1 compares very closely to the R value of the fiber, but more particularly the difference between the R value of the bubble and the R value of the fiber is 12.4. So these values match up pretty closely. And so what that really shows is there's no real way to game the system, right? I kind of thought that just a thin barrier between the bare metal would kind of give me something that would make a big enough difference for me to kind of care about it. But the conductive heat transfer through that bubble insulation is like almost nothing. So there's very little conductive heat transfer insulation provided by that type of insulation, which is why it's not really designed for that. It's designed as a radiant barrier, which is why it has the foil reflective coating on it. Whereas the fiberglass insulation is more of a conductive heat barrier. And so, yeah, that's pretty much it. So there's no real way to game the system. The R values matter. R values, they're additive. So if you take an R value of 5 and an R value of 6 and sandwich them together, you get an R value of 11. So yeah, good luck with whatever installation projects you're running. I'm going to try and make sure the shop stays pretty well insulated. So, like I said, you can't beat physics, and you can't beat, kind of basic heat transfer properties. So, don't think that there's a way to game the system. And be careful when you're looking at packaging for insulation. If they're claiming like a really high R value for really thin insulation, it's probably because there's an asterisk at the end of that that says that under these very specific circumstances, it's possible to get a particular R value. And chances are whatever application you're using that for is not going to apply to that test circumstance where they got that R value. So just bear that in mind, and good luck with all your projects. Anyways, if you haven't liked and subscribed, make sure you do that. Hit the bell so that way you get notifications for on any future YouTube videos I put up. Thanks for watching, and yeah, go check out my other videos. Thanks.